Now we take up some problems based upon what we have discussed for continuity. First question is, find the value of the constant k such that fx is equal to 1 minus cos 2x over 2x square if x is not equal to 0, and k if x equal to 0 is continuous at x equal to 0. Now the definition of the function for x less than 0 and x greater than 0 is the same. For x less than 0 and x greater than 0, it is same. So we can consider both the limits together. We need not consider left and right limits separately. So what we do is, in order to check the continuity, we have to check that limit x approaches 0, fx and value of the function at x equal to 0 are both equal. So first we find limit x approaches 0, fx. First we find limit x approaches 0, fx. Now x approaches 0 means x is not equal to 0. So x is not equal to 0. So definition of the function is limit x approaches 0, 1 minus cos 2x over 2x square. So in limits, we have studied two formulae. You can see the side sheet. Limit x approaches 0, sin x over x is 1, and limit x approaches 0, tangent x over x is 1. So we reduce such questions into these two formulae. So what we know is, from trigonometry you must remember two very useful formulae. First is 1 minus cos 2 theta is 2 sin square theta, and 1 plus cos 2 theta is 2 cos square theta. These are very useful formulae. You must keep them always in your mind. So 1 minus cos 2x can be written as limit x approaches 0, 1 minus cos 2x will be 2 sin square x, and denominator is 2x square. So this cancels and we have limit x approaches 0, sin x by x whole square, and this is equal to 1. Because limit x approaches 0, sin x over x is 1. So this limit is 1. Now for continuity, limit x approaches 0, fx is equal to f of 0. Value of the limit must be equal to the value of the function, and this implies limit x approaches 0 from fx is 1, and value of the function at the point 0 is k. So k must be equal to 1 is the answer. This implies k is equal to 1 answer. So we must take k equal to 1 if the function has to be continuous, because its value must be equal to the value of the limit at that point. And second is, discuss the continuity of the following functions at the indicated points. Now first question is, we have fx is equal to 2 mod x plus x square whole divided by x if x is not equal to 0, and 0 if x is equal to 0. Then the point to be considered is x equal to 0. So now here modulus is involved. So we must take left and right limits separately. So limit x approaches 0 from positive side fx must be equal to limit x approaches 0 from positive side means x approaches 0 from positive side means x is not equal to 0. So this definition will be used. So 2 mod x plus x square over x. Now we know that x approaches 0 from positive side means x is greater than 0. X is greater than 0. And therefore mod of x must be equal to x. So mod of x must be equal to x. Therefore this must be equal to limit x approaches 0 from positive side 2x plus x square whole divided by x. So what we do is limit x approaches 0 from positive side, we take x common and we get 2 plus x over x. So this x and this x cancel and we get limit x approaches 0 from positive side 2 plus x, and this is equal to 2. If we put x equal to 0 here, so answer will be 2 into 0 plus 0. This will be in the form 0 by 0, and 0 by 0 is an indeterminate form. That is, the question is not yet solved. You must remove the indeterminate form to get the answer. If it is in the form 0 by 0 or infinity by infinity, this will mean the question is not yet solved. It is indeterminate. And similarly, if limit x approaches 0 from negative side fx, then this will be equal to limit x approaches 0 from negative side 2 mod x plus x square whole divided by x. And this is equal to, as x approaches 0 from negative side, x is less than 0. Therefore mod of x will be equal to minus x. So we will get limit x approaches 0 from negative side 2 into minus x plus x square by x. And this is equal to limit x approaches 0 from negative side, take x common. X is common, we get minus 2 plus x over x. So x cancels and we get limit x approaches 0 from negative side minus 2 plus x. So this is equal to minus 2. Therefore, limit x approaches 0 from positive side fx is not equal to limit x approaches 0 from negative side fx. Therefore, function is discontinuous at x equal to 0. And note, x equal to 0 is a discontinuity of which kind? Of first kind. Because limit x approaches 0 from positive side fx exists, its value was 2, and limit x approaches 0 from negative side fx also exists, its value is -. Both the limits exist but are not equal. Now the next question is, we are given fx equal to x minus 1 mod plus mod of x minus 2. We have to discuss the continuity at x equal to 1 and x equal to 2. Now modulus of x minus a is defined as minus x minus a if x is less than a, and this is equal to x minus a if x is greater than or equal to a. So what we notice that definition of this function changes at the points 1 and 2. So what we do is, this is the number line. These are the points 1 and 2. Now what we note is, for x less than 1, x minus 1 is negative. For x less than 1, x minus 1 is negative. And for x greater than 1, x minus 1 is positive. X minus 1 is positive in this interval. And in this interval, x minus 2 is negative. X minus 2 is negative. And in this interval, x minus 2 is positive. X minus 2 is positive. So what we notice that in x less than 1, both x minus 1 and x minus 2 are negative. And in this interval 1 to 2, x minus 1 is positive and x minus 2 is negative. And in this interval, x minus 1 is positive and x minus 2 is also positive. So what we do is we break this number line into three intervals. From x less than 1, 1 is less than equal to x is less than 2, and x greater than equal to 2. Here x minus 2 is negative and x minus 2 is positive. And in this interval, x minus 1 is negative and here x minus 1 is positive. So what we notice that in this interval x minus 1 is negative and x minus 2 is also negative. In this x minus 1 is positive but x minus 2 is negative. And in this interval x minus 1 is positive and x minus 2 is also positive. So what we notice that in these three intervals this function is having different definitions. So we break this number line into three intervals. X is less than 1, 1 is less than equal to x is less than 2, and x is greater than equal to 2. X is greater than equal to 2 because x minus 2 is positive in x greater than equal to 2. So equality we are including here. And here also mod of x minus 1 will be x minus 1 if x is greater than equal to 1. So here we are including equality. So what we do is we write this function as fx is equal to. First interval will be x less than 1. Next will be 1 is less than equal to x is less than 2. And third will be x greater than equal to 2 and x greater than equal to 2. So in this interval x is less than 1. X is less than 1. X is less than 1, x minus 1 is negative. So we have minus x minus 1. X is less than 1, this will be negative. And for x less than 1, x minus 2 will also be negative. It will be negative, this is negative, this is negative. Minus x minus 2. And in this interval, x minus 1 is positive and x minus 2 is negative. X minus 1 is positive. So we will have x minus 1. And x minus 2 is negative. Therefore, we will have minus x minus 2. And in this interval, x minus 1 is positive and x minus 2 is also positive. So both are positive. So we will have x minus 1 and plus this will also be plus x minus 2. Or in a very simple way, you can take a point in this interval. In this interval, take say 0.5. Put 0.5 here. It is negative, so this will be negative. 0.5, this will be negative. This will be negative. Because throughout this interval, the sign will remain same. So sine of x minus 1 and x minus 2 throughout this interval is same. So what will be sine of x minus 1 and x minus 2 throughout the interval will be same as that at a single point. So instead of checking the sine throughout the interval, we will check it at a single point. So you can check the sine at a single point in this interval, single point in this interval, and single point in this interval. It will be same as that of x minus 1 and x minus 2. So quickly you can do it like this. Not in this interval, take a single point, 1.5. 1.5, this is positive. At 1.5, this is positive. So we are taking positive side. So 1.5, this is negative. So sine of this at 1.5 is negative. Therefore, it will remain negative throughout this interval because the sign will not change in this interval. And take a single point in this interval. Take 2.5. 2.5, this is positive, so we are taking positive. 2.5, this is positive, so we are taking positive. So instead of checking the sign throughout the interval, you can take a single point in these intervals and check the sign, because the sign is not changing from here to here, here to here, and here to here. So you can very quickly write this. And this is equal to, now minus x is minus 2x. Minus 2x minus plus 1 plus 2. So plus 3 for x less than 1. And in this interval it is x minus x cancels. Minus 1 plus 2 is 1. So 1 is less than equal to x is less than 2. And in this interval, it will be x plus x is 2x, minus 1 minus 2 is minus 3, x is greater than equal to 2. And equality, in these inequalities, we are taking for x greater than equal to a. So for x greater than equal to 1, we are taking equality here. And here also x for x greater than equal to 2. So equality for 1 and 2 is being taken at x greater than equal to 1 and x greater than equal to 2, because we are taking this definition of mod. So we have simplified this function into this form. Now we find the continuity at, say, x equal to 1. X equal to 1. Now limit x approaches 1 from positive side, fx is equal to. Now x approaches 1 from positive side means x is greater than 1. And x is greater than 1 is included in this definition. So definition of the function will be this one. So it is 1. And so value of this limit is 1. And limit x approaches 1 from negative side fx is equal to. Now x approaches 1 from negative side means x is less than 1. And x is less than 1, so x is less than 1 is included here. So definition will be this. So this is limit x approaches 1 from negative side minus 2x plus 3. So this is equal to x is 1 to minus 2 plus 3, and this is equal to 1. And value of the function at the point 1. Value of the function at the point 1 is x equal to 1. X equal to 1 is included here. So value of the function is 1. So what we note is limit x approaches 1 from positive side fx is equal to limit x approaches 1 from negative side fx is equal to f of 1. Therefore x equal to 1 is a point of continuity. So x equal to 1 is a point of continuity. Function is continuous at x equal to 1. Now we consider x equal to 2. X equal to 2. Limit x approaches 2 from positive side, fx is equal to. Now as x approaches 2 from positive side, x is greater than 2. And x is greater than 2 is included in this definition. So limit x approaches 2 from positive side, from here is 2x minus 3. And this is equal to 2 2s are 4, 4 minus 3 is 1. And limit x approaches 2 from negative side, fx is equal to. Now x approaches 2 from negative side means x is less than 2. Therefore x is less than 2 is included in this definition. So limit x approaches 2 from negative side of 1, and this is equal to 1. So what we note is limit x approaches 2 from positive side, fx is equal to limit x approaches 2 from negative side, fx is equal to value of the function at the point 2, because at x equal to 2 this is 2x minus 3. So 2 into 2 is 4, 4 minus 3 is 1. This each equal to 1. All these are 1. This is 1, this is 1, value of the function is also 1. Therefore x equal to 2 is also a point of continuity. Therefore the function is continuous at x equal to 2. So function is continuous at both x equal to 1 and x equal to 2. So in such questions I told you that what you do is fx equal to x minus 1 plus x minus 2. So divide the number line into 3 intervals. This is x equal to 1, 2. So one interval is this much, second is this much, third is this much. And then change fx to this one. And for doing this, take a single point. Take a single. Divide the number line into 3 and then take a single. 0.5, negative, negative. Then take 1.5, this is positive, this is negative, positive, negative. And then take 2.5, this is positive, this is positive. And quickly write this. And then limit is very simple. In the previous question, to make ideas clear, we did a lot of discussion. I take one more similar example to make you understand how this has to be done in a practical question. So one more example. Discuss the continuity of fx is equal to 2x minus 1 plus mod of 2x plus 1 at x equal to half and x equal to minus half. So we are given the function fx is equal to mod of 2x minus 1 plus mod of 2x plus 1. Now if we put 2x minus 1 is equal to 0, we get x is equal to half, and 2x plus 1 is equal to 0, we get x is equal to minus half. So what we do is we break the number line at these points. Say this is 0, this is say 1, this is minus 1. So what we do is we break the number line into 3 intervals. X equal to minus half. So this is x equal to minus half and this is x equal to half. So what we do is we break this number line into x less than minus half is less than equal to x is less than half, and x is greater than equal to half. So what we do is we write fx as fx is equal to, break this into 3 parts. First is x is less than minus half. Second is minus half is less than equal to x is less than half, and third is x greater than equal to half. Now in x less than minus half, take any one point. Now any one point can be minus 1 here. In this interval, take any one point, say minus 1. Now put minus 1 here. When we put minus 1, we get minus 3. So this is negative. So we will have minus 2x minus 1. Now x equal to minus 1 here. This is minus 2 plus 1. Again, this is negative. So we write minus 2x plus 1. Bas. In this interval, again take a single point, say 0. Put x equal to 0. This is negative. So we will have minus 2x minus 1. And in this put x equal to 0, we have positive. So this is positive. 2x plus 1. Because when we put x equal to 0, we get 1, which is positive. So it will be a positive sign here. Now in this interval, take any one point. In this interval, take any one point. Any one point can be 1. So put x equal to 1. So this will be 2 minus 1 is 1. So we get 2x minus 1. And x equal to 1, this is a positive. So we will have plus 2x plus 1. And this is equal to, now minus 2x is minus 4x minus plus. So we have minus 4x plus 1 minus 1. This is plus 1 and here we get minus 1. So we get this. So x is less than minus half. So this is equal to minus 4x for x less than minus half. And in this interval we have minus 2x and 2x cancel. This is minus plus 1 and plus 1 is 2. This is 2 for minus half is less than equal to x is less than 1 by 2. And in this interval, this is 4x, minus 1 and plus 1 cancel. We have 4x. This is 4x. In x greater than equal to 1 by 2. So this is how in practical situation we have to proceed. The discussion involved in the last question was to make you understand the concepts. In practical questions, you straight away do it like this and arrive at the result. Now, limit x approaches 1 by 2 from negative side, say, fx. We have to discuss the continuity at 2 points, x equal to half and x equal to minus half. First is x equal to half. X approaches half from negative side, fx. Now, x approaches half from negative side means x is less than half. So x is less than half. X is less than half is here. So this definition will be used. Limit x approaches half from negative side 2 and this is equal to 2. And limit x approaches half from positive side fx is equal to limit x approaches half. Now x approaches half from positive side means x is greater than half. X is greater than half. Now x is greater than half in this here. So this will be 4x. Now put x equal to half here, we get 2. Now third thing is f of half, value of the function at the point involved, that is half. So x equal to half, we will get the value from here. This is 4 into half, that is 2. Therefore, limit x approaches half from negative side fx is equal to limit x approaches half from positive side fx is equal to value of the function at the point half. Therefore, fx is continuous at x equal to half. Therefore, fx is continuous at x equal to half. at x equal to minus half, you can try yourself. Try yourself. This is simple. You can try yourself. Now, before taking up the next question, I will like to discuss a very useful tool known as synthetic division or single line division. Suppose we have to divide a polynomial, say x to the power of 5 minus 2x cube plus 3x minus 4 by, say, x minus 2. X minus 2. So what we do is we complete this polynomial. Write this as x5 minus 2x cube plus 3x minus 4. This is written as x5 plus 0x4 minus 2x cube plus 0x square plus 3x minus 4. Complete the polynomial. You can do this step orally and write the coefficients. And now from here write the coefficients of all powers of x. So coefficients are 1. Now x4 is 0. X cube is minus 2. X square is 0. X is 3. And constant term is minus 4. And write the divisor. If this is x minus 2, then put this equal to 0. This will give x equal to 2. So write 2 here. If it is x minus 2, write 2. If it is x plus 2, write minus 2. Minus 2. Now what we do is, this is the starter. We write 1 here. And multiply 1 with this. 1 into 2 is 2. Write this under the next term. 2, add them. Multiply by this, place under the next and add. So 2 into 2 is 4, place under the next and add. 2 into 2 is 4, place under the next, add. 4 into 2 is 8, place under the next and add. And 11 into 2 is 22, place under the next and add. We get 18. So quotient is, if we divide this polynomial by x minus 2, quotient will be x to the power of 4. So this is the quotient of x to the power of 4. From here we get x4 plus 2x cube, x4, x cube, x square, x and constant. Constant x, x square, x cube, x 4. You can calculate from here also. Constant x, x square, x cube, x 4. So what we get is this plus 4x plus 11. And remainder is equal to 18. So this is the quotient and this is the remainder. If in a question you get remainder as 0, then this will mean x minus 2 divides this polynomial. That is, x minus 2 is a factor of this polynomial. So one of the factors will be x minus 2 and the other will be this. If remainder is 0, then this and this will be the two factors. I will illustrate it by taking an example. One more example I am taking. Now next is divide x cube plus 5x square plus 5x plus 1 by x plus 1. So what we do is we write the quotients of all the terms here. 1, 5, 5, 1. And this will be, if I put this equal to 0, I will get minus 1. Or we can write x plus 1 is equal to x minus 1. So we must write minus 1 here because rule is for x minus a. So we have to find a and write a here. So here a is this, but simply you can put x plus 1 equal to 0. So we are getting x equal to minus 1. So write minus 1 here. So this is the starter. Now multiply with this, place under the next. Multiply, place under the next, add. Multiply, place under the next and add. This is the rule. So this is minus 1, add. This. Multiply by this. This will be minus 4, add 1. Multiply by minus 1, place under the next and add. So this is 0. So remainder is 0. So what we see is that this polynomial is divisible by this. So quotient is constant x square. So x square plus 4x plus 1. And remainder is 0. So we note x plus 1 divides this polynomial. Therefore x plus 1 must be a factor of this polynomial. So we can use this tool for factorization. We can write x cube plus 5x square plus 5x plus 1. And since the remainder is 0, so this will be one of the factors, x square plus 4x plus 1. This is one of the factors and other will be x plus 1. So this can be used for factorization. And one very important theorem is, if fx is a polynomial, then x minus a is a factor. Then x minus a is a factor if and only if f of a is 0. If fx is a polynomial, then x minus a is a factor if and only if f of a is 0. So here you put x equal to minus 1 in this polynomial. What we get is minus 1 plus 5 into minus 1 square is 5. 5 into minus 1 is minus 5 and plus 1. So this is equal to 0. So we know beforehand that this will be a factor of this polynomial. Because on putting x plus 1 equal to 0, we get x equal to minus 1. And put minus 1 in place of x, we get 0. F of a is 0. So we know x plus 1 will be a factor of this polynomial. This theorem is known as factor theorem. If you put x equal to a in a polynomial and the result is 0, then x minus a will be a factor. Now one more important thing is indeterminate forms. If you have a question which is in any of these forms, 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power of 0, or any of these forms, then this will mean that the question is not yet solved. It needs further simplification. These are all indeterminate forms. We cannot determine anything about these forms. We need further simplification. As an aid to memory, we can understand it like this. If, say, this is any finite number and this tends to 0, then the answer will be plus minus infinity. Plus minus infinity, depending upon whether numerator is positive or negative. Finite and this tends to 0, finite to 0 will be plus minus infinity. And if we have this is finite and this is 0, then 0 multiplied by any finite number will be 0. So answer will be 0. If this is 0 and this is finite, answer is 0. If this is finite and this is 0, answer is infinity. And if two numbers are equal, answer will be 1. So we cannot say anything about this. It will be 1, infinity, 0. What the answer will be, we cannot say at present. Similarly, in this case, 1 over infinity. If denominator tends to infinity, then 1 over infinity will be 0. and infinity over any finite number will be infinity. Infinity divided by 2 is infinity. Infinity divided by 3 is infinity. So infinity divided by any number will be infinity. And any number over infinity will be 0. And if two numbers are equal, answer should be 1. So we cannot say anything about this, whether this is 0, infinity or 1. And similarly, anything multiplied by 0 is 0. And anything multiplied by infinity is infinity. So we cannot say what the answer will be. And infinity minus infinity. Now infinity plus 100 is infinity. Infinity plus 200 is infinity. So what will the answer be? Infinity minus infinity. What will be the answer? And similarly, anything to the power of 0, any non-zero number to the power of 0 is 1. So will 0 to the power of 0 be 1? We cannot say. And similarly, infinity to the power of 0, will this be 1? Or what will be the answer? We need further simplification. And 1 to the power of infinity. If a number is less than 1, then that number raised to the power of infinity will be 0. And if number is greater than 1 and we raise it to the power of infinity, answer will be infinity. So what will be the answer if number is 1? So all these forms are indeterminate forms. If any question is in any of these forms, this will mean we need further simplification. You can keep this in mind. So with this background, I take up the next question. Now we are given fx is equal to this much. And we have to prove that it is discontinuous at x equal to root 2. So first of all, we find limit x approaches root 2 fx. Now for x less than root 2, definition of the function is this. For x greater than root 2, definition is again the same. So we need not consider left and right limits separately. So we find limit x approaches root 2 fx. So this is equal to limit x approaches root 2. Now as x approaches root 2, this will mean x is not equal to root 2. So this definition of the function will be used. So we will have x4 minus 4 divided by x square plus 3 root 2x minus 8. Now when we put x equal to root 2 here, what we observe is root 2 to the power of 4. This is equal to root 2 to the power of 4. This is equal to 2 to the power of half to the power of 4. So powers will multiply. So we will have 2 to the power of half into 4. That is 2 to the power of 2. That is 4. So what we have is 4 minus 4. That is 0. So we know beforehand that x minus root 2 will be a factor of this polynomial. X minus root 2 will be a factor of this polynomial by factor theorem. And similarly, when we put x equal to root 2 here, what we get is root 2 square is 2 plus 3 root 2 into root 2 minus 8. Root 2 square is 2. 3 root 2 into root 2 minus 8. So we have 2 plus root 2 into root 2 is 2. So 3 into 2 is 6. 6 minus this is equal to 0. So we again have 0. So again we know by factor theorem that x minus root 2 will be a factor of this polynomial. And what we notice, this is in the form 0 by 0. This is in the form 0 by 0, which is indeterminate. That is, the question is not yet solved. We must remove this indeterminate form. 0 by 0 is indeterminate. So what we do is we write x4 minus 4 is equal to x square minus 2 into x square plus 2. And this is equal to x minus root 2 into x plus root 2 into x square plus 2. We are using the formula a square minus b square is a minus b into a plus b. So these are the factors of this polynomial. Now to find factors of this polynomial, I am deliberately using synthetic division. You can do it by the methods you have learned in lower classes, but I am deliberately using synthetic division. So now in synthetic division, what we do is we write the coefficients of all the terms in this polynomial. So what we write is coefficient of x square is 1, coefficient of x is 3 root 2, and coefficient of constant term is minus 8. No term is missing. So divisor is root 2. X equal to root 2. So root 2 is the divisor. Now what we do is, this is the starter. 1 we write here, multiply by this. We write root 2. Add, multiply by this, place under the next, and add. These are the keywords. So 4 root 2. Now multiply with this, place under the next. So 4 root 2 into root 2 is 8. Place under the next and add. So this is 0. So this confirms that x minus root 2 is a factor of this polynomial, because remainder is coming out to be 0. So what we can write is x square plus 3 root 2 x minus 8 is equal to, one of the factors is x minus root 2. Root 2 here, so x minus root 2. And the other factor is, this is constant, this is x. So x plus 4 root 2. So these are the factors of this polynomial. Now we substitute these in 1. We substitute 2 and 3 in 1. What we get is limit x approaches root 2 of fx is equal to limit x approaches root 2. Now x4 minus 4 is equal to x minus root 2 into x plus root 2 into x square plus 2, x square plus 2. And factors of this polynomial are this, x minus root 2 into x plus 4 root 2. This is equal to limit x approaches root 2. Now x approaches root 2, x approaches root 2, therefore x is not equal to root 2. Therefore x minus root 2 is not equal to 0. So this term is not equal to 0, therefore it can be cancelled. This is not equal to 0, and therefore we can cancel this term. So this term cancels and we are left with x plus root 2 into x square plus 2, and this is x plus 4 root 2. Now when we substitute x equal to root 2 in this, we will have root 2 plus root 2, that is 2 root 2, and root 2 square is 2, 2 plus 2 is 4. So this is non-zero and this is also non-zero. So now we have removed this indeterminate form. Now the question is not in 0 by 0 form, and we can directly substitute the limit. So what we get is root 2 plus root 2 into root 2 square is 2, 2 plus 2, and this is equal to root 2 plus 4 root 2, that is 5 root 2. So this is equal to 2 plus 2 is 4, 2 root 2 into 4 by 5 root 2. So root 2 cancel when we get 8 by 5. So this is 8 by 5. And this is not equal to value of the function at the point root 2. Therefore, function is discontinuous. Therefore, fx is discontinuous at x equal to root 2. So value of the limit is not equal to the value of the function. Therefore, function is discontinuous. And this discontinuity is a removable discontinuity. Now in this question, we have to find k such that this function is continuous at x equal to 1. Again, what we see is for x less than 1, definition of function is this. For x greater than 1, it is again same. So we need not consider left and right limits separately. So in order to find k, what we will do is we will find limit x approaches 1 fx and equate it with the value of the function at x equal to 1. So what we do is we first find limit x approaches 1 of fx. This is equal to limit x approaches 1 of fx. Now as x approaches 1, x is not equal to 1. Therefore, this definition will be used. We will have x4 minus 3x cube plus 2 whole divided by x cube minus 5x square plus 5x minus 1. Now, if we put x equal to 1, so 1 minus 3 into 1 cube is 3 plus 2. 1 minus 3 plus 2. So 3 minus 3 is 0. This is 0. Numerator is 0. And we know when on putting x equal to 1, this is 0. Therefore, x minus 1 must be a factor. And similarly here, put x equal to 1. This is 1 minus 5 plus 5 minus 1. 1 cancel, minus 5 plus 5 cancels. And we have 0. This is again 0. So what we notice, x minus 1 is a factor of this polynomial, because on putting x equal to 1, this is becoming 0. So by factor theorem, if f of alpha is equal to 0, then x minus alpha must be a factor. So on putting x equal to 1, we are getting 0, so x minus 1 must be a factor. Now we factorize these two polynomials and separate the factor x minus 1. You can factorize these by traditional methods. I am using synthetic division for giving you practice. So this is now for this polynomial x4 minus 3x cube plus 2. What we do is we write the coefficients. First coefficient is x4 is 1, x cube is minus 3, x square is 0, x is 0. Constant is 2 and divisor is 1. X minus 1 has to be the factor. So this is equal to, this is starter 1, multiply by this, place under the next and add. Minus 2 multiply by this, place under the next and add. Multiply by this, place under the next and add. Multiply by this, place under the next and add. Remainder is 0. So this is confirmed that x minus 1 is a factor. And factors of this polynomial are x4 minus 3x cube plus 2 are x minus 1 into. This is constant x square, x cube. So this is x cube minus 2x square minus 2x minus 2. These are the factors. Similarly, we factorize x cube minus 5x square plus 5x minus 1. Write the coefficients of all the terms. 1, x square is minus 5, next x is 5, and next is minus 1. None of the coefficients is missing. So, and we write the divisor here. So this is the starter. We write 1. 1 into 1 is 1. Place under the next and add. Multiply by this. Place under the next and add. Multiply by this. Place under the next and add. Remainder is 0. So we get the factors as x cube minus 5x square plus 5x minus 1. This is equal to x minus 1 into. Now this is constant x square. So we get x square minus 5x plus 1. So substituting these factors in, this is a 1, this is 2, this is 3. So substituting 2 and 3 in 1, what we get is the limit x approaches 1 of fx is equal to limit x approaches 1, and numerator is from 2, it is x minus 1. You can see the side sheet. X cube minus 2x square minus 2x minus 2, and denominator is x minus 1 into x square minus 4x plus 1. Now x approaches 1, therefore x is not equal to 1, therefore x minus 1 is not equal to 0, and therefore we can cancel x minus 1. So this gets cancelled because this is non-zero. We must verify that this is not equal to 0 before cancelling it, because if it is 0, it cannot be cancelled. For example, 0 into 3 is equal to 0 into 6. Cancel this, we'll get 3 equal to 6. So whenever you cancel any factor, you must ensure that it is non-zero. Then only it can be cancelled. Now this cancels, and when we put x equal to 1 in numerator and denominator, what we see is this is non-zero and this is non-zero. Now this is not in 0 by 0 form. The indeterminate form has been removed, and therefore we can directly put the limit. X equal to 1. 1 minus 2 minus 2 minus 2 whole divided by 1 minus 4 plus 1. So this is equal to minus 5 over minus 2. This is equal to 5 by 2. Also, f at 1 is equal to. Now, in the statement of the function, what we see is that function is equal to k when x is equal to 1. So when x equal to 1, value of the function is given to be k. For continuity, limit x approaches 1 fx must be equal to f of 1. This is the condition for continuity. And this is 5 by 2 and f of 1 is k. Therefore, k is equal to 5 by 2. Answer. So value of k is 5 by 2. This question and the previous one, we are using factorization as a method to find the limit.